Is that coming through clear? Okay. So it's been a few weeks now. There's been a move. There's been all kinds of different life changes and stuff going on. Still moving closer to the baby being born sometime within the next month. So things are busy, but continuing to inch along through the LLMs from scratch book. I have a new section to air today. So this would be coming out of the first and second chapter. The first one being where it's mostly focused on sort of architecture and just the foundations of transformers and what LLMs emerged from as a paradigm. And then in the second chapter, we were looking a little bit more at text embeddings and how to take the textual data and tokenize it, convert it into the vector space that a machine learning model or an LLM can actually be trained on. This would be a numeric representation. So then getting into the third chapter, we are now past the initial curation of training data, and we're now starting to dig into the attention mechanism specifically. The next few are actually, I think what are going to be the more interesting aspects. Preparing text data, just any sort of data preparation process. It's not the fun part. It's the very necessary part to curate actual training data that can be used to build and fine-tune any sort of machine learning model. It generally tends to be most of the work. At least most of the actual human labor is just curating together and deciding on what data to include in your training. But now we're getting to the phase where in chapter 3, 4, and 5, we're starting to talk about how the actual attention mechanism works in LLMs. And this is referring back to the 2017 paper, Attention is All You Need, that started the newer paradigm. Then in chapter 4, I think we start to get into actually building out our version of an LLM, and then we'll be training it. We're doing some initial training runs in chapter 5, or first version of a GPT model. So let me grab one of the notebooks. I have a couple actually. In this process over the last month, I actually started to put together a foundations notebook as well. That focuses a little bit more on just the sort of trad ML side of things as it's relevant to LLMs. You can grab that real quick. Okay, so we're gonna go with screen one here. And all right, hopefully you can see my editor here. So jumping over here, as you can see, I've got a couple different notebooks. Over the past couple of weeks, I've been going through, first was just validating a dev environment setup and making sure that you've got PyTorch set up properly and that it's working. In this case, because I'm using a MacBook, we're using a version that's compatible. We're using the MPS version so that we can actually take advantage of Apple Silicon. Then chapter 2, at the top here, this is a notebook that I've also pushed to the repo. And this is entirely focused on working with the textual data, as I was just discussing a second ago. So this just kind of goes through that process of understanding how word embeddings actually work, what it looks like to tokenize text. You can see here where you've got this input training data that we have, and a snippet from it goes from this sentence to then being broken out into all of its component parts. We go through a couple different ways or approaches of doing that, and then showing what this actually looks like once you've tokenized the corpus, that full text corpus. And then it goes into actually converting those into token IDs. As you can see, every single one of those characters becomes a numeric representation that the weights in this neural network can then be trained on. Anyways, so this gets into the weeds of that process. It goes through BPE or byte pair encoding, data sampling, and the sliding window. So like how much at a time, like how many tokens it's actually looking at a particular point, or basically grouping those different tokens together. Testing out some tensors with those, and then creating token embeddings. So basically, this one is, if you haven't actually had a chance to check through these, if you're following along in the book, if you wanted to study any of this particular topic, I've been going through this Build a Large Language Model book by Sebastian Rauschke for the last month, and these two notebooks are just ones that I've kind of put together for my own process of review and just breaking it down into the component parts, understanding how each step works. And so I basically just put one of these together each week. And so far, they tend to be lining up with each chapter. All right, so then I have a 3 here. So this is where we're getting into coding attention mechanisms. So this is kind of the area I'm at right now, but I just published this notebook, so if this is something that you want to start digging through, this is specifically set up in a way that works on MacBooks. That's what I'm on. So it might be convenient for you. The stuff that's from Sebastian's book, the book was written in 2024, all very still valid, but some of it needs to be updated to actually work locally on your computer. So this notebook is just basically breaking down, why attention exists. I've included some visuals in here to actually try and make the learning process a little bit less just purely numeric and tensors, because it's a little bit more intuitive to see some sort of graphed out data rather than just looking at an array of numbers. Let's see. This particular one also includes we'll call it a capstone at the end. It's basically just taking the first 3 chapters that we went through and basically tying that process together. Taking the text data that we put together, the initial PyTorch setup, and then basically training a very small subset of what will eventually be a larger GPT, just to test that process actually works. The other thing that I include in these is a little bit of an exercise at the end of each of these sections to encourage myself and anybody else that looks at these to basically take the stuff that they've actually walked through in this notebook before and then start to fill that out and think through the process, think through how those things work, and see if you even just read one of these questions and say, I don't necessarily have enough context to understand exactly what I need to do for that particular task. That's a cue that, okay, maybe I need to dig in a little bit or like rewind a bit and go and familiarize with a particular section that I probably skimmed over on here. And then if I can start to actually scratch something out in these cells and do it manually, because, at this point, we're all using tons of generative tools to do a lot of the work for us. So this is an effort to try and encourage a little bit of manual programming, manual scripting to put together the different components of what we're learning so far. Refer to some of these other cells and then apply it into a smaller script within the notebook that then you figure out how to get working. Perhaps with just contextual help from search, from Claude, whatever, but not literally writing it out. So this is basically where I've gotten to right now. There is one other piece that I wanted to share as I'm getting into this attention mechanisms area. I think it's good to jump backward, and I had put together a notebook specifically on ML fundamentals. So tried ML concepts like linear regression, where when you have a collection of data, you're trying to find a sort of trend line or project a trend line through it. And I also included some useful videos in here to just kind of show the process. Because I find it's kind of helpful to see some of these things happening in real time. Just watch that for a moment play out. So basically just doing training iterations on the data to reach a better fit. But we also go over loss functions here, which is what at the end of the model we resolve an outcome to. So this digs into some concepts like cross entropy, which, I mean, I for one definitely needed to refresh on some of these topics myself. And this also follows a similar format. So you've got sections at the end of each of these where you can actually just familiarize with the stuff above and then try to, rather than just running code from these blocks, try to actually go through, try to do an exercise, answer some of these questions by writing something out, doing something here, applying what is being explained here. This also covers logistic regression, as well as backpropagation. I think I actually had, just like a simple neural network visual in here as well. Let's see your loss function at this last network node here. And then we have movements back across the network. Let's see what other nuggets were in here. Also, a deeper dive on neural networks. This is something, I mean, if you're ever looking at roles that are related to machine learning or AI engineering broadly, a lot of these TradML questions tend to come up still. Even if a lot of these things, like you're not necessarily building a neural network from scratch, or an LLM from scratch in most cases, honestly. Generally where I've ended up applying this kind of, where I've ended up applying LLMs to real problems, I'm not building something from scratch to the degree that we're going through and actually curating text data like this and then trying to train a foundation model. Most of the time, what I've ended up doing is, and I think a lot of people who've done this professionally, you look at the latest open source available tools, you look at the latest cloud available tools, and depending on the situation that company is in, if they are very concerned about keeping all of their data on-prem and closed access, they don't want any third-party companies being able to use any of their proprietary information as training data. Then you need some sort of closed system. You can't use an API from OpenAI or Anthropic. So you end up needing to pull some sort of open source model, because that 9 times out of 10 makes way more sense than trying to build something from scratch. You can then fine-tune a lot of these very capable open source models to a particular business case, whether that's like a customer service bot that's going to be answering questions on your website, to like a call center conversation bot, to one that is ingesting legal docs and outputting summaries. Basically, you would want to fine tune an open source model. There's probably some that have already been fine tuned for this, but if you have your specific data set, you can use that to fine tune the openly available model and run it on your own hardware. And then you don't have a third-party company that is ingesting that data. So this process, it's kind of like going through LeetCode code or doing data structures and algorithms. Even after you've been doing a lot of this stuff, where you've been working in software development for years, coming back to the TradML stuff and concepts is still something that will come up in interviews. And you'll get asked a question like, oh my gosh, like what is overfitting or underfitting, for instance, and need to actually talk through what that means. So we have more visuals here as well. So my understanding for overfitting and underfitting is generally if there is always a balance to be found in the amount of training runs that you want to do with a particular data set. And if you overtrain the model on that particular data, it will become overfit basically to that data. And then when you give it something that is not in that training set, it could give you a overly confident answer, basically, or an overly confident probability at the end of the model output for a particular classification or outcome. And if you undertrain it, then you get something that is a little bit too noisy and is not really accurate enough yet, or producing useful outputs yet on new data that it hasn't been trained on. And so the problem that you're trying to solve is do we run more training iterations or less in order to find somewhere in that middle? And there's many processes to find a balance for that based on the data that you're working with, the size of the models. Let's see, what else do we have in this one? Bootstrapping and bagging. This one actually came up in an interview as well recently. So I think this one's useful to review. So two acts in this section. So first, the bootstrap for uncertainty, more confidence intervals, and then the second, resampling trick repurposed for better models or bagging. So bagging so let's train one model per bootstrap resample and then average their predictions per bootstrap sample. Hold on. So I actually need to review this particular topic, which is why I included it in this notebook. So bootstrapping answers with, let's see, classical statistic answers with formulas that require one slope, one accuracy, no sense of how much to trust it, a particular model output. So bootstrap answers this by brute force. You resample your own data set with replacement, same size, some points appear twice, some not at all, and refit. Each resample is a plausible alternative data set. So basically, when I had a conversation about this a few months ago, the situation that came up is that you have a limited amount of data available, not really enough to reach a useful level of fitness for the model that you're trying to train. And one way to curate more data is to take the same limited data set that you have and change some subsets of it in a very targeted nature. So you resample certain parts of that data set, replace certain parts. You make it slightly different enough that it might actually be useful to retrain the model and further tune it towards the amount of the fit that you need for that particular use case. So then you can do that many times and then basically average out. Let's see, I think bagging is averaging the predictions from many different, from one model. Let's see, so far bootstrap measured uncertainty. So bagging train one model per bootstrap resample and then average their prediction. So you train a different model on each different bootstrapped data set that you've put together. And then you take, say you train 10 different models on 10 different bootstrap variations of your original data, and then you average together the values or their prediction outputs. And so that, as you can imagine, if they all are a little bit all over the place for each individual one, if you're averaging them, you almost get a sort of like group contribution and reach a sort of bell curve value between them, and you can resolve that basically to the mean of those prediction values. Both of these seem to be ways of overcoming limited data, and then in the process of bootstrapping a larger data set that you did not originally have in the original form, you then need to cancel out some of the noise that you create by doing so, potentially. And so that is where bagging comes in. There's also moving on here, there's a recurrent neural networks section here as well. So that might be something worth digging back into. Again, all of this, it's not necessarily in the Machine Learning from Scratch book, but they are topics that are relevant to everything that is being done in this book, because LLMs are fundamentally based on a lot of the same techniques, just built on top of those foundations. Anyway, that is where I am at as of this week 3, that I've been going through this book. I'm excited to start getting into the actual attention mechanisms section now, and spend a little bit more time focusing on a lot of this content. I need to internalize a little bit more of this stuff, and then going into chapter 4, where we actually start building out a model. So applying a lot of these different techniques into the construction of an LLM. So getting into the meat. Hopefully, if you actually had a chance to jump in and check any of this out so far, you're also finding useful. I would love to hear if anybody is interested in particular topics that have come out of this, or a particular area that you found useful. You could drop that in the comments, or feel free to send me a DM if you want to jump on and actually talk about any of this as you've been going through it, and sort of what has been driving you on this particular topic also, in your own professional or personal interests. So I'd be happy to pull some other people in for oncoming weeks to discuss further as we continue to move through the sections here. Other thing, this book is leading into a future iteration that the author is going to be releasing as I think later this month, and that is building a large language reasoning model. So specifically an LLM that also has this ability to have a sort of reasoning dialogue loop that it then, so you basically give it a prompt, it thinks, it has a process that it goes through to try and deliberate on the best output before actually then providing the final response to you. All of this also just digs back into some of the ideas that I was getting really fascinated with over the last couple of weeks, around, we were talking about the Jacobian space and the global workspace that had come out of some recent research from the Anthropic team. So I am looking forward to digging further into this topic and getting to the stage 2 area of actually building the foundation model. Anyways, looking forward to what's coming next, and I will send out the latest updates from the repo, so if anybody finds this and wants to go and check out the notebooks in there, they will be at the GitHub link that is posted with this video. Anyway, thanks for your time. I will see y'all next week.